Today we're talking about cybersecurity in space. You might not think that spacecraft are vulnerable to hacking, but we know there have already been attacks on US satellites, and we can expect more. So our question is, how can we protect these critical national assets and make them resilient to these kinds of attacks? Fortunately, we have a person who can answer those questions. To answer that question and maybe others, we're going to be joined by Greg Falco today. Dr. Falco is a professor in the School of Mechanical and Aerospace Engineering at Cornell University. And viewers will be taking your questions in the chat today. By the way, today's keynote, it's the latest installment, the fourth installment in a series brought to you by the New York Consortium for Space Technology, that's NYCST, and we'll drop some links to those recordings of previous events in the chat so you can get up to speed on what's going on in the space industry here in New York. So let's get into it. Welcome, Greg. I want to ask you to start us off with a story. Can you tell us about a cyber attack in space, maybe even one of the first ones?
Yeah, so this definitely wasn't the first cyber attack in space, but it was the first one that was publicly discussed. And so back in 2007, 2008 timeframe, there were two US government satellites. One is called Landsat 7, and the other one was called Terra AM1. And both of these satellites were Earth orbiting satellites, and at least Landsat 7 was made for doing some climate science and some just Earth observation. And so what happened was back in 2007, 2008 timeframe, these two satellites were taken over. One was taken over for 10 minutes and one was taken over for 12 minutes. And when we say taken over, we mean that the ground station, the people who were operating the US government, lost complete control over these satellites for 10 minutes and 12 minutes, respectively. And we didn't hear anything about this until I think it was 2011 timeframe. So that was like 4 years later, where we started hearing hints, and it was mentioned in a congressional committee on Chinese competitiveness, where it was disclosed that they believe that China broke into the ground station that was commanding these satellites and used that opportunity to break in and be able to take command and control over the satellites. And this was interesting because you might wonder, like, why did they do anything over the 11 and 12, the 10 and 12 minutes respectively for those satellites being taken over, if it was China? And if you look back a little bit further in time, in early 2000s, China kind of made some really interesting doctrine about space supremacy, how they're going to command the space regime in the future. And they mention explicitly that their goal was to hijack satellites. And they did. So it was a very great demonstration that they had the capability, they had the power to do this. And they didn't want to do anything bad with it. They just wanted to show the US, look, we can take over your satellites if we want. And how that happened and how that played out was actually through a ground station that the US commanded in Svalbard, which is an island that Norway controls and owns in the Arctic. But, this is kind of the first time the US back in 2011 had actually publicly disclosed that, yeah, we were taken over and these satellites were satellites.
So Sputnik in October of 1957, that was widely seen as a demonstration by the Soviet Union that they could send an ICBM anywhere on the Earth, right? If you can send a satellite into space, you can presumably send a missile that high and that far and land it wherever you like. So it was kind of a demonstration to the US that the Soviets had the capability. So you're saying that China is demonstrating that same thing. Why demonstrate it? Why say that it's possible as opposed to just keep that capability quiet and then exploit something when you want to?
It's a great opportunity to show that you have a plan and that you can execute on those plans and that you should be worried. And that is part of China's playbook for a lot of things, right? They write it out in doctrine and then they demonstrate they can do it, and they don't act on it. They don't do anything malicious with it necessarily, but this was a great example of them sticking to their playbook and showing that they can execute on their technical priorities.
So, but showing us, I guess what you're saying, showing the US.
Showing the US, showing the world, right? It's not just the US. They just want to have national pride and demonstrate to the world that they can do something, and they can.
So in this case, this is they're effectively attacking the ground station and therefore indirectly the spacecraft, right? In other words, did they have access to the spacecraft through some other means, or was there some other malicious activity going on other than whatever was directed to the ground station to get them control of the ground station per se?
So they actually had command and control over the space vehicle itself. So when you attack the ground station, you aren't able to directly control the vehicle from that ground station command. You can't like inject commands into the queue for the vehicle to actually have the vehicle do something. In this case, they actually were able to command those vehicles to actually do things that they wanted it to do. Now, the U.S. didn't disclose what it was doing during that time when they had command and control over it, right? That's not something that was in the public documents. But the fact that it was said they didn't just take over the ground station, they took over the vehicles and they had absolute authority over those vehicles over the time, makes a technical expert assume they were messing around with something inside the vehicle itself. They were sending commands directly to the vehicle and they were locking out whoever else normally commanded that system.
As a result, we have no record of the commands that were sent.
Yeah, well, we don't have public insight into that.
Public.
I'm sure, yeah, publicly. Yeah, this is something that's important to note too, right? Like this type of activity probably has happened for many years, even before the 2007, 2008 timeframe. It's just that you don't ever hear about this in the public. It's usually classified material.
So cybersecurity is pretty familiar to a lot of us. Anyone who's used a computer grumbles about two-factor authentication or the continued data breaches that we get notices in the mail about. And so this is not like it's not like there's a surprise that it's possible for anyone to employ some kind of cyber attack against a terrestrial computer system, whether it's your own personal computer and there's a risk of getting ransomware that'll, I guess, threaten to delete your data or do something else with it unless you pay some Bitcoin to some guy in Russia, or whatever else the issue might be. So there are companies out there that specialize in protecting an individual's or corporation's assets, the government's assets, at least for terrestrial matters. So, for example, the computers that are used for command and control of things in the government, or a business's own accounting computers, or the other things that you take for granted in a day-to-day existence, other than space. So coming up next, we have a video from a company called Orbital Fire. They are an NYCST member. Again, that's the New York Consortium for Space Technology. We'll play their video, and then we'll talk about what we'll talk about the context that they're operating in, which is a more or less traditional cybersecurity domain. And then let's think about how it might be different for space. So play that video, please.
My name is Reg Harnish. I'm the founder and CEO of Orbital Fire Cybersecurity. At Orbital Fire, we are mission-driven to make cybersecurity accessible to even the smallest organization. Many of our customers make up manufacturers in the defense industrial base, or others who are pursuing CMMC compliance or NIST 171 best practices. We provide complete solutions for organizations who are in that mode, and that ranges from assessments and testing through workforce security, training, education, testing, a full managed SOC, incident response services, as well as becoming the virtual chief information security officer for the vast majority of our customers. Now, our specialty is in simplifying and making accessible all of these complex solutions that exist in cybersecurity. If you believe NIST, there are about 1,000 things that you could be doing, but honestly, there are a fraction of those that actually make sense for smaller organizations. Our specialty is taking those large frameworks and solutions, simplifying them for smaller organizations while making sure that they're still effective. Why is cybersecurity important? Well, I think a few things are important to dispel. Our industry does a great job of scaring, shaming, bullying, and confusing folks. The reality is cybersecurity is a practice that we implement to protect your business and to create competitive advantage, to keep your best customers, to earn cyber insurance and other protections for your business, and then ultimately to protect the mission of the business. Just like you wouldn't send a rocket ship into space without shields and other types of defensive mechanisms, you wouldn't send your business into the competitive landscape without protecting it as well. Now, Why is protecting space important? Well, for us, we recognize that organizations like you who are working in these areas where of space exploration or of other engineering, technology, and other amazing things that are happening in this industry, a couple of things are really important. From a cybersecurity standpoint, we recognize that there are different economic consequences for organizations like you who are working in the space industry. Obviously, an emerging area for everyone, something that is maintained, continues to be unexplored and is innovative. Secondarily, there are different political consequences for organizations who are working in your space, and they tend to be much more radical. We recognize that your competitors aren't necessarily just looking to outprice you. They may be looking to steal your intellectual property and take it to market for a fraction of the cost. And then ultimately, there are entirely different human consequences to organizations who are in the space industry. Sending people to Mars or into space on rocket ships or other vehicles, and all of the technology and process and engineering that goes into that, every one of them have a very different potential outcome if we don't secure them appropriately. We're here to help you, regardless of what your mission is, and regardless of what role you play in the space industry. Cybersecurity has become a cost of doing business, but really a competitive advantage, particularly for smaller organizations. My name is Reg Harnish. I'm the founder and CEO of Orbital Fire Cybersecurity.
All right, so Greg, a lot to talk about there, but in particular, what's your takeaway? What should people take away from this?
Yeah, so I think one thing that was mentioned was how there are hundreds of recommended controls when it comes to cybersecurity. And when NIST, which is the National Institute of Standards and Technology, comes out with a bunch of guidance on cybersecurity, these are usually industry agnostic. And the guidance is useful, but it's sometimes overwhelming, especially for, as was mentioned, small organizations, but even more so, sometimes it's not always highly relevant to every specific type of industry. And it's really important to figure out how to prioritize for the size of the organization, but also the type of organization. And space companies or space mission operators sometimes have different priorities than others. So let's break that down for a second. If you are a commercial space company, the main thing that needs to happen is you need to make sure that you are always connected. You got to make sure your mission is always up and running. And why? It's because your revenue is your lifeblood. You need to make sure that your data is your lifeblood. You need to make sure that you're operational so that someone can be charging someone for the services that are required.
Just to be clear, for folks who aren't living and breathing the stuff the way that you and I are, so a commercial space company would be a company who's making money off of some kind of space services. For example, they might operate geosynchronous communication satellites, or maybe an example, SpaceX using Starlink satellites for internet or data. And so they're making money off of that without explicitly, or at least not primarily a national security purpose, right?
Exactly, yeah. And thanks for clarifying that. So those types of companies have different priorities, different mission priorities than, let's say, NASA, for example, which often says that their mission priority is the science. And so if their science gets disrupted, that's a really bad day for them. And that disruption comes in the form of maybe someone breaking one of their sensors or their payloads on the end device, or maybe making it so that they are never able to get communication back to the ground for some really sensitive information they were able to capture. And so it's actually a different type of problem than the SpaceXs are dealing with, right? Because for SpaceX to continue making money, for Starlink to keep making money, they have to have consistent data flow, right? They always have to have information. No one can ever block that, or they're not getting money for it. NASA wants to send something from deep space. They need to send it back once, or twice, or it doesn't matter. The latency might be okay to have a high delay. So it's a different priority of what you need to secure for that type of mission versus the commercial mission. And this has ramifications on the types of security controls that you might want to enable for your organization to prevent attackers from breaking those things. You also might require different types of designs, security designs for these systems. But I'll stop rambling there.
No, that's very interesting, and I guess I'm wondering whether the general guidance then that exists, these 1,000 different recommendations that might exist, is it that there's a subset that's relevant to space, or is it in fact a superset? Are there some issues that are space specific that really aren't contemplated for folks who can offer solutions for terrestrial cybersecurity?
Yeah, it's a great question. Well, so over almost about a year ago now, at that time, Vice President Kamala Harris, who was kind of chairing the National Space Council, came out with a requirement saying, hey, we need to have minimum requirements for space systems from a cybersecurity standpoint. And so I chair the IEEE International Technical Standard for Space Cybersecurity, and so has it that we were trying to design minimum requirements for space system cybersecurity at the time. And what came about from this effort is for us to figure out how do we actually say, based off of a very specific mission priority, how do we decide what part of the space vehicle or the ground system or the link segment, the communication mechanism, what part of that has to be secured in order for that mission priority to actually be met. So it becomes a question of how do you match the end goal of your space thing to what is the main engineering design requirement that you have to actually match. And that really depends based off of the type of company you are or the organization you're working with, and also what you have to work with. So if you're a government, you're building the Golden Dome, spending tens of billions of dollars on an asset or a system, it's a very different cybersecurity mission priority than a CubeSat, launched by a university.
Sure, that makes sense. Another way of asking that question is to talk about the unique elements of maybe the network stack or the so-called attack surface, and maybe you can define those terms for us. But a question from Vikram online is exactly that. The OSI stack does not change whether it's on Earth or in space. So he asks, what, if any, are the unique elements of the network stack and the attack surface that differ in space infrastructure? Are there specialized tools needed to protect them, or are existing tools sufficient? So first, maybe you could define OSI for us and talk about attack surface. These are sort of terms of art. I don't want to say jargon, but it's fairly specific to this problem. And it might be helpful just to kind of get the discussion moving beyond the specifics, understand those basic ideas. And then please do, if you can, talk about whether there's something unique about that network stack or attack surface for space.
Sure. So I'll start with the notion of attack surface, because that's broadly a more understandable construct, where we have a whole bunch of different technical components, and those different technical components might be things that an attacker might want to break. And those technical components become our attack surface. Now, when it comes to a space mission, we have a variety of attack surfaces. We have what we call the ground segment. So it's the satellites, it's the computers, it's the server infrastructure where you're typing in commands, and you have operators or you have mission control, and they are hanging out there, putting information in and saying, okay, eventually this has to get up to the satellite to go do something. That's one part of the attack surface. What that usually looks like from a cybersecurity standpoint is not terribly different than a server, a bit of server infrastructure. Like you might house your email server, or it might look like an industrial control system, similar to how the electric grid operates. There's certain network components that are part of that, which have its own constraints. So that's what makes up our ground system. Then you also have what we call we have our user segment. Our user segment is what the end user has to interact with, who's receiving the services from space. So it's different than the ground segment, because the ground segment is the people who are putting the information in, and it goes to the satellite, and then the satellite does something. And then sometimes the satellite beams information back, and our end user like you or me might use our phones in order to get a GPS signal and understand where we are at a given time. So another attack surface, back to that word, is the devices that we are using to get the information back from space. Then you have another type of attack surface, which is the actual space vehicle itself. And that attack surface is a whole bunch of technical components, meaning there's a computer on board, there's a whole bunch of sensors. Now, one of the things with that's notable there is it is a highly constrained system. So you don't have a lot of computational power. You have latency concerns. So how long something will take to get to point A to point B is a consideration from a cybersecurity standpoint. And an attacker might want to directly attack what is actually happening on the vehicle itself. That's another attack surface. And then you have one final attack surface called the link segment, which is the RF, the radio frequency communications. It's the physical link layer between the ground segment and the space vehicle, and now increasingly between one space vehicle and another space vehicle. It doesn't have to be radio frequency links either. It could be free space optical links, so a laser, which is actually relaying this information. So an attacker might want to disrupt that communication asset itself. So based off of that, we have these 4 different attack surfaces. We have the ground segment where we're able to write commands and send it out to space. We have the user segment, which is the device that an end user of space services might want to engage with. We have the space vehicle itself, which is the satellite in orbit. And you have the link segment, which is this physical layer of either a laser or radio frequency environment where you are able to break as well through jamming or other means. So those are kind of 4 different types of attack surfaces that are relevant. And if you ask me what the difference is between that and other systems, the quick answer is some of those systems have the exact same problem as other cyber systems. So for example, on the ground segment, if you're dealing with an email server, you have the same problems as you would have dealing with your email server at home. But on the space vehicle, you have a different type of device with different considerations. Because it's constrained, it has size, weight, and power constraints. And so you have to deal with that in a different way.
Yeah, so spacecraft, being constrained in size, weight, and power, we call it SWAP, right? The SWAP constraints, do you think on the whole they make it easier or harder to exploit vulnerabilities? Or another way of saying that is you can obviously throw a ton of software at a problem, and maybe that's a good thing, maybe not, but you don't have that option sometimes on a spacecraft. You might have a fairly limited amount of memory, even more limited processing capability. But does that mean it's a harder problem? Or in fact, are the vulnerabilities actually that much more limited because the resources are also limited?
So having these limitations makes it easier to create a space brick, where you can't actually work with the satellite anymore. It is definitely more difficult for an attacker to have maybe a more sophisticated type of attack where they have to do a whole bunch of computation on the endpoint that they have to operate on. It's also challenging because it's easier to be seen and caught if it has less resources to be messing with, right? So if I am an attacker and I'm breaking into the space vehicle, I have to be able to make my movements or my commands look like a regular command so that some fault detection mechanism is not going to just kick that out of the system immediately. But if I want to just have some kind of more blunt force tool of destroying something, it's very easy to knock that offline because there's the redundancy mechanisms. The backups are just not quite there for these SWAP constrained environments.
So we've talked about this before. You and I came to kind of an understanding that space maybe lags other technical domains in terms of dealing with cyber issues or security issues. I don't know if you'd agree with that, but that's, I think, roughly where things tend to stand. So it's surprising in some respects that these very expensive and sometimes national assets are so vulnerable. At this point, though, this, thanks to your work and the work of others who are working in your field, we've come to understand these vulnerabilities. I think you articulated very successfully the 4 different aspects of the attack surface. So do you think that now at least we understand the problem, or are we still a little foggy on the problem itself? In other words, understanding the vulnerabilities. Do we recognize what they are?
I think in name, we understand the vulnerabilities, right? Now we can have open conversations about what the risks look like and why something might break versus not break. But And maybe just to that point, it took a long time to get there because, as I had described very early in our conversation, a lot of this material was locked behind closed doors for many years. There was not a lot of publicly available information about how these attacks might work, or information about existing systems that were attacked because they were sensitive. But because there's more discourse on this, there's a lot more that we can do to have conversations and actually promote the idea that security has to happen on these systems. So we've come a long way with just being able to talk about these things, but we haven't come a long way necessarily in doing much about these things. And part of the reason for that is there's the notion in space of needing something that is that has been space rated or space tested or having been a legacy system, right? We want it to have flight heritage. That's always a question and a problem when it comes to anything that has to do with space. We want to make sure that it's been proven on a previous mission. So being able to get to a point for cybersecurity measures or cybersecurity tools that people are comfortable with, we have to have demonstrated that and given those systems flight heritage. And so this is something now we still have a pretty big curve to meet in the industry, because we haven't had a sufficient number of missions tested with different cyber remediations, because it's just kind of a new topic that people are talking about publicly. And it's going to be a long time until we have a whole bunch of accepted tools that are usable by the space community.
Yeah, the old expression is it can't fly until it flies, right? So that puts us in a kind of an awkward position. In fact, there's another notion of heritage and legacy, and I guess the very precise definition of those things matters, right? So heritage, as you say, is has it flown before? And if so, it's probably a good thing because we have some trust in it. Legacy sort of means the same thing, but it also means you're stuck with it, or can mean you're stuck with it. So a legacy solution, not to pick on any particular company, but let's say there existed some McAfee antivirus from the 90s that was installed in some ground system. That's their legacy solution, even though it may have, at this point, lots of vulnerabilities or other issues. Again, not picking on McAfee in any way, but as a specific example, something that may be 20 or even 30 years out of date is still a legacy solution, but it's a legacy in the sense that you've inherited it from a predecessor or from an earlier version of the same thing you're working on now. And you almost regret having to stick with that old creaky apparatus. So yeah, it kind of cuts both ways, right? So if you have a heritage solution, that's something you're proud of. If you have a legacy solution, it's something that maybe makes you roll your eyes a little bit. Either way, we're not quite there yet, I think is your point, for space. And we don't have the luxury of being able to roll our eyes at that old cybersecurity solution for spacecraft. But even then, we're talking about single spacecraft, right? I would imagine as this coming future gets closer and closer to us, this future in which we have multiple spacecraft interacting, almost certainly autonomously, interacting not only with other satellites, but also with, let's say, infrastructure hubs. Those could be for power or refueling. They could be for communications. You could have, for example, network nodes in space transmitting data to and from the ground and to space. So all of that infrastructure, that space infrastructure, which to be clear, barely exists right now. But if it were to exist, I would imagine it opens up a whole other layer of vulnerabilities. I don't know if you'd call that more of an attack surface, but it does strike me that there are vulnerabilities that arise because of the nation's potential investment in a future of refueling in orbit. Say, for example, you're able to come up with a way in which the autonomous refuelers never refuel spacecraft. That's a really quick way to eliminate those spacecraft needing to be refueled from being able to put into service. So I would think that that's another thing on the horizon. It's not only that you're chasing the bad actors. As they become smarter, you become smarter ahead of them or behind them. It's actually that the entire nature of space systems is changing. In fact, it's going to change for other reasons too, right? You recognize that there is thanks to SpaceX's Starship and Super Heavy combination, the cost to orbit could be as low as maybe $10 a kilo in the coming decade. If that's true, maybe what's at stake for cyber and space changes in ways we can't even contemplate. I mean, certainly you could argue if things are so inexpensive, do we care to protect them? I would say we probably do, certainly because the consequences of not protecting them are quite dire. But the spacecraft themselves might be more or less disposable. So there's a whole lot of rambling thoughts there, but mostly what I'm trying to get at, Greg, is we are chasing multiple problems at the same time. There's getting us up to date with the cyber environment, the cyber landscape. There's also anticipating a future with an infrastructure in space and lower cost to orbit. I don't know how those all play together. What's in your crystal ball?
Yeah, there's a lot to unpack there. I think the first part of it is that there's an amazing amount of commercial companies who are going to be taking a major role in that future of enabling space operations. So you mentioned SpaceX, Amazon and their Kuiper satellites, and Blue Origin's, which I guess Amazon's sister company of sorts, that is also enabling more readily available launch infrastructure in the future. Looking at some of the advancements of intuitive machines, which has been trying to get to the moon, right, and trying to have successful lunar landings. These are all commercial companies that have motives that are outside of the national security space, outside of science, and exploration to actually advance this field. And so back to how does that play a role? Something that we're going to continue to grapple with is as these companies become really important permanent infrastructure of the field, they don't always have the incentive to secure their systems because that financial metric that they're always using is either aligned to, well, let's keep my service running, or let's make sure that we are compliant with the bare minimum requirements that the government makes us have for launch infrastructure. Cyber is not always something that people want to pay for. And it's something where we're going to get to in the near future this increased friction point of can we operate at a scale and at a very low expense to the point where security actually doesn't matter, where we can just throw up new assets without having any concern for the fact that it breaks? Or do we start thinking about it from how do we enable this as a highly regulated environment where the government requires different things in order to be up there? And this is something that the community is struggling with a little bit right now. Over the past year and a half, there was a bunch of dialogue between the White House and commercial sector and the defense industrial base about what is the right level of conversations that should be had about this and requirements that were put in place. And obviously, almost no one met eye to eye on that. So I think the future is uncertain right now because if we rely heavily on commercial sector and things are really inexpensive to launch and really inexpensive to operate, security might not be something people want to prioritize. It might end up as a nightmare for us to deal with after the fact. Similar to how IoT devices today with your smart toasters and your smart refrigerators are used in these massive botnets to run ransomware attacks or denial of service attacks against internet providers. That could happen too in the future. But again, we don't know yet how that interface is going to happen because the commercial sector is taking so much of a role in the future. I think you're on mute, Mason.
This is another good transition to a question from online. So you mentioned your role as the chair for a standards organization, IEEE, right?
Yep.
And the question is, is there work ongoing on standards akin to NIST for space infrastructure? Now that's infrastructure, maybe not necessarily for cyber, but can you say something about the maturity of requirements for cyber for space or national guidance?
The maturity varies based off of what you're wanting to secure. So for many years, there's been an organization called CCSDS, Consultative Committee for Space Data Standards. It is an international organization that now allows for the U.S. government, NASA, to engage with Roscosmos, to engage with ESA and all the other national space agencies. And they essentially, in this organization, they just agree on data standards to make sure that they are all able to talk to each other for their machine-to-machines interface. Now, they've been working on data security for a while in terms of data protocols. So some of that might have some maturation in terms of a consensus across international government organizations saying we want to agree to this level of encryption on some data infrastructure, some space infrastructure. But that's very different than saying I'm going to build a space vehicle and it's going to be secure. Because the design of that space vehicle may vary a lot based off of the mission, and it also might have nothing to do with data, right? It might have everything to do with the actual system design or the hardware requirements or the physics of how you actually enable the payload to be collecting information. So some of that world, the design requirements and the design standards for cybersecurity is not mature today, which is why we're building a new standard for this. But if you look at some of the data standards that have been around for many years, that's just kind of continuing to kick a can down the road of, oh, how do we improve the encryption? How do we make sure everybody can communicate this payload data with this ground station over here? So it really varies in terms of the maturation of the standardization community. And it also varies based off of what country you're talking to, or if you're talking about a government sector versus the commercial sector.
So there are plenty of tools that we use to address these problems in general. Obviously, your lab, your research at Cornell, has a whole utility belt of tools that you deploy to try to develop new space cyber software, let's say. I'm trying to abstract it in a way that's going to make it accessible. You can do a better job, I'm sure. But one question from online, from Malin from Sweden. How can AI be used to improve cybersecurity for space? I think there's a risk that we can ask that question for anything. How can AI improve how I cook tomato sauce? And that's it probably can. But this is the question for you. So is there an opportunity to leverage AI or maybe even machine learning to train up some cybersecurity mitigation?
Yeah, to not make sure I don't sound like one of those old academics that are like, billion years ago I invented this thing. But like number of years ago, my dissertation was actually on developing AI systems to automatically break into space mission systems. And it was something that this was over 10 years ago now, I think, around 10 years ago. Yeah, that I was working on this. And AI has advanced a lot since that period in terms of the accessibility of these tools. And so I think AI has been better at breaking these systems than they have been at figuring out how to create defenses and fixing the systems.
That's interesting.
And that's something where the community has a lot more work to do to provide assurances over how you can use AI to actually fix the systems. But we're pretty comfortable today with seeing how we can deploy it to break systems.
Do you think that bad actors will be using AI to break systems?
I mean, they absolutely already are, right? And any attacker, any hacker would be remiss in not using the tools that are available just through, openly available large language models like, ChatGPT or Grok, to be able to just use those to break systems. You'd be an idiot as an attacker to not use those systems to help you with your objectives. And so we already are seeing this, at scale as a general cybersecurity problem. It's definitely true of space as well. But again, we have a little bit of a way to go about still how do we trust those systems to enable defenses for these space missions.
Sense. So let's go back to our general questions about space cyber. One of the aspects of this thing is that clearly it's not simply a U.S. problem, it's a global problem. And after all, space is effectively a global phenomenon in the sense not of Taylor Swift being a global phenomenon, but rather the orbits that spacecraft are in surround the entire Earth. This notion that a spacecraft traveling over a country is violating its airspace has already been dispelled through various treaties over the years. Furthermore, there are various space treaties to which the U.S. is a signatory to, relatively few, but one of them is the 1967 Outer Space Treaty. All of those set forth a set of basic rules, like, for example, that you can't put offensive weapons in space, you can't own space, and there's other things that have to do with what it means to be a state actor in space. With all that in place, and again, the fact that there are these treaties in place for most countries, international cooperation seems essential. But I imagine that there are legal challenges. For example, having the U.S. try to collaborate with a non-U.S. partner implies all sorts of export control regulations start to become important, as well as many other layers of security. So, as important as international cooperation is, I imagine that there are impediments. Can you say anything about that, about the international aspect of this?
Yeah, I mean, maybe I'll start with just saying it's great that these treaties have existed over years about international engagements, but no one follows these treaties. So it's something where it's very important to note that from a cyber standpoint, because we don't want to limit the research that's done, and we don't want to have countries say, well, I'm not going to be engaging in looking into how do we build out cyber systems for space because it's not a warfighting domain and we are everything's peaceful and we don't own anything in space. Like that's not the reality that we live in compared to what the treaties say. And so I think that's important to start with. But assuming that people are not following a lot of these treaties in many ways, it's important then for us to think about based off of what we actually see happening for the commercial sector, what we see happening in national security space sector, and for civil space organizations. We have to engage in different we have to use different approaches to work with the international community. So, for example, in science, we generally try and keep our information largely open and have consistency across how we would be sharing international design standards for building out a space system. And this is where these voluntary technical bodies like IEEE or ISO become very relevant because you're sharing information about how do you build a good baseline of security from the ground up for anyone who's engaged. And these working groups, for example, the one that I chair has over 200 members in it from around the world. We have like 35 countries that are engaged in it right now. And so that's a great opportunity to actually engage with other countries and share open information about security. When it comes to commercial sector, you referred to some of the ITAR controls and other types of controls that might be around dealing with space and security. And this has become a huge impediment to collaborations internationally when new technology has been developed that is also used for the national security sector. And it comes down to this notion of dual use, which is very prominent in space, where you have a commercial asset. So you might say, okay, I'm going to use this satellite to go take pictures of a given area to be able to value insurance packages, right? So you might say, I want to go look from a Earth observing satellite and I want to use it as a climate imager and say, okay, we're going to get a lot of rain this year, so I'm going to price that insurance very high. But at the same time, that satellite image can be used by a military system to be able to target something or to be able to do reconnaissance on something. And so that dual use capability of that asset becomes challenging for the commercial sector to be able to start sharing security information about, because it does have military implications. And so this is something where there's a lot of friction right now relating to how companies are able to start sharing things internationally and selling things internationally, because there are US restrictions on how this is done. And so it gets even more hairy when you're looking at exclusive national security space problems relating to sharing information internationally, where the US is generally restricted from sharing most information on space and security. Sometimes it can share within the Five Eyes, which is the US and Australia, New Zealand, Canada, and the UK. But they don't really share much beyond that when it comes to national security space information. So it really varies depending on if you're looking at the commercial sector, the national security space sector, or science.
We have a take on that with another video from one of our guest contributors here. It's from Mike Green. This video goes into some of these in more detail and provides some interesting examples of attacks. Let's hear from Mike.
Hello, and thank you to the eCornell and New York Consortium for Space Technology for including NORTEC in today's conversation. I'm Mike Green, Partnership Directors from NORTEC, a Department of Defense-funded regional innovation hub focused on accelerating the lab-to-fab transition for critical technologies in microelectronics, secure edge computing, and quantum systems. My background spans defense technology, intelligence operations and development, and advanced systems development. supporting everything from kill chain integration at BAE Space and Mission Systems and Ball Aerospace to capability development at Johns Hopkins University Applied Physics Lab and at the Navy's Cyber Warfare Development Group. Today's space systems are not isolated, and that's why cybersecurity in space matters. These systems are part of a deeply connected ecosystem that spans on-orbit, cloud, edge, and terrestrial networks. That connectivity brings tremendous capability, but also risk. The attack surface is growing, and at its core are the microelectronics that power space systems, the processors, memory, FPGAs, and sensors. These components are often globally sourced and integrated into mission-critical platforms, making them vulnerable to supply chain compromise, tampered firmware or updates, edge attacks in contested environments, and radiation-induced or malicious fault injection. We've seen real-world incidents of these taking place. One recently in 2022 was the Viasat KA-SAT cyber attack, which used a ground-based vulnerability to brick tens of thousands of satellite modems, disrupting wind farms, emergency services, and civilian broadband access across Europe. So this wasn't a space asset getting shot down. It was a digital attack on ground infrastructure tied to a space system, launched by a state-aligned actor on the same day as Russia's invasion of Ukraine, which is quite the coincidence. So as a space system developer, this incident validated a focus on resilient hardware, edge compute, and full lifecycle trust, from silicon fabrication to system deployment. Microelectronics are both the backbone as well as the Achilles heel of modern space systems. That's why at Nortech, we're investing in secure chiplet packaging, trusted AI/ML at the edge, hardware-based authentication, and tamper resistance as examples. We receive our direction from the DoD and work with over 35 partners, industry, government, and academia on technologies that can survive the complex space ground user environment. Another example, consider the SolarWinds breach in 2020. Russian actors compromised software updates from a trusted vendor, infiltrating thousands of networks undetected. That same threat model applies to firmware updates in satellite ground stations or IP cores in a space-qualified FPGA. Our work at Nortech looks to ensure these systems have hardware-based trust anchors. So even before launch, we know what's on board and that it hasn't been tampered with. So accelerating resilience from lab to orbit is also an important topic. Cyber resilience in space is not just a software problem. It's a materials, hardware, and systems integration challenge. And at Nortech, we're supporting projects like QPIX and HQWin, which are developing foundational qubit architectures, heterogeneous quantum networks at the chip and system level, and tools for secure, low latency communications and resilient compute in degraded environment. And so currently, quantum systems are not at the edge of being operationally fielded. They're long-term investments for the DoD. But with increasing threats from both state and non-state actors, now's the time to build the foundation technology and do the initial research and development into these systems with cybersecurity in mind. Here's another example. In 2024, the hacktivist group NB65 claimed to breach Roscosmos ground systems, leaking their control software as well as collected imagery data. Whether fully validated or not, when it comes to the specifics, it still highlights a dangerous trend. Cyber attacks on national space systems are no longer limited to nation states. That's why our work on quantum resilient architectures, secure configuration, and trusted microelectronics is so critical, and why we've partnered with AFRL, Cornell groups, RPI, IBM, and the University at Albany to push these capabilities forward. Now, we've spoken about technology developments and how cybersecurity is needed for these technologies and operational systems. But education and collaboration amongst the workforce and industry is also needed because technology alone won't solve this. We need a workforce that understands both semiconductors and security, materials, and mission assurance. Nortech is building that pipeline through hands-on prototyping at New York Creates, Cornell, and RPI. And there's a need to embed threat awareness into engineering education. Each of the examples I mentioned, the Viasat attack, SolarWinds, and the NB65 attack, involved human error or blind trust, weak credentials at the system level, misconfigured systems, and also unverified updates. All of these are operator vulnerabilities and vulnerabilities that should be identified by the operator. So we should continue to not just train people to build chips, but also include training to build secure systems from the ground up. Space resilience, as with anything that involves operational deployment, begins way before the integration and fielding of these systems. It starts at the foundry level, at the firmware level, and at the edge. At Nortech, again, we're focused on making those layers secure, resilient, and built to last. And if you're a part of an organization that is working in secure compute, photonics, or quantum, we'd love to interact and hear from you. We're always looking for collaborators to bring tomorrow's mission-assured systems to life. I'd just like to thank again the eCornell and New York Consortium for Space Technology for having me today and for allowing us to talk about this important challenge going forward. Thank you.
All right, Greg. There's a lot of great stuff in there. One of the things that Mike offered was so much more recent attacks compared to the Landsat attack. Can you say something about the level of sophistication? Were these more recent attacks more sophisticated in some way, or did they show off new vulnerabilities we didn't realize existed?
Unfortunately, they're not that interesting, these
Okay.
recent attacks. And it's not because they're not interesting, it's just that they technically weren't necessarily any more sophisticated than you could have done 20 or 30 years ago at this point. It's just that it kind of demonstrates that the same issues that we had back when Landsat 7 and Terra were broken in by the Chinese, like same stuff exists today, same holes in people's network exist. And we really haven't done much about it necessarily. If anything, it also shows that now our commercial sector is much more vulnerable to these systems. It's not just government satellites that are vulnerable, as Viasat is a commercial company.
So, question from Stephen Wood online. This will probably have to be our last question. He asks, the violation of airspace by assets is settled, geosynchronous satellites in the Bogota Declaration, he cites, but because the demarcation between atmosphere and space is unsettled, China's been using language to define the demarcation to their benefit using technology or terminology like near space. What does that mean, and is it under terrestrial or space laws? Ultimately, generally settled in the main, but on the edges there seems to be some room for potential legal argumentation. And if this is the case, Greg, my general take is that while we could agree or disagree over, we're talking about 100 miles or 100 kilometers, it's some number like that is the edge of space. I don't know that there is disagreement over the fundamentals of what an orbit is, but I could be wrong. Does this kind of legal sophistry come into play at all when you think about cybersecurity?
Not really, because the technology that's used for these very high altitudes are consistent with satellite technology. And so when we are looking at, so recently we published a paper on high altitude platform systems. So very high altitude balloons or VLEO operations, which are very low Earth orbit. And the security concerns for them are very similar to the ones that you'd have in low Earth orbit or in MEO or GEO or deep space. And so I don't think from a technical standpoint, it's actually changed the game much based off of the altitude that we're talking about. Legally, that's less of an area that we are playing with, but I think there could be some gray area in terms of regulations and requirements based off of your altitude in the future, the same way that people try and hack uh, the height your car is off the ground in order to get rid of different vehicle emission requirements, right? Like, so I can see that being the case in the future from a security standpoint, but right now from a technical standpoint, it doesn't really matter to us.
So one of the things you commented on with these other attacks, these examples of other attacks from Mike's video, is that they're not necessarily that much more sophisticated. We still have the same vulnerabilities. So let me ask you to look a little bit farther into the future and answer the question, what does the future hold? Are we on a good path, do you think, to addressing these issues, these security issues for space that will get us where we should be in the near future? Or is there more danger ahead? I mean, right now, if you think about various spacecraft and the harm they could do to the Earth, I would have to think that something like the GNSS, the Global Navigation Satellites, are the ones that have probably the most likely impact. It's not like there's a massive bomb in low Earth orbit waiting to be dropped on someone at the command of a hacker. So if that's the kind of vulnerability, corruption of data or denial of not denial of service in that sense, but being denied access to our assets, if that's the kind of primary vulnerability, are we on a good path, or is there some other danger ahead that we don't know about?
Yeah, as our reliance on space infrastructure becomes more intense, I don't think we're on a great path right now necessarily. And the reason why is just because we just don't have a lot of control over. When I say we, I think that I kind of mean the government does not have a lot of control over what it's telling commercial companies should be going into these systems as they design them. And just a quick anecdote is part of a program that I run for NATO is rerouting some of the subsea cable infrastructure into satellite communication. So how do we reroute the internet that relies on fiber to satellite communications? And as we have a lot more satellites to play with, as we have Kuiper and Starlink and OneWeb, and now also the Chinese have their own mega constellation, we're going to begin relying on that infrastructure significantly because it's now redundant paths to get information around. And so I don't think we've been thinking about how we're going to now become so much more reliant because it's going to become cheaper and more affordable and more ubiquitous. And we really haven't gotten there yet from a risk mitigation standpoint. So there's a lot of work to do, and it's a great field to be in if you want to start a company or you're interested in doing some research in this area.
Great point. And I guess we're saving the best for last here. Maybe as we wind this down, can you give us just a summary of the cool things that you guys do in your lab? And I imagine you'd be happy to invite folks interested in pursuing a PhD in this area to get in touch, and maybe there's some potential for work with your lab. But yeah, what are the things that you guys are innovating on right now?
Yeah, so there's a couple of buckets that we like to think of ourselves as doing cool work in. Some of the areas are relating to just discovering or coming up with new ways of breaking things. That's always fun. But we also have to make sure that that is grounded in scientific rigor and reproducibility and physics to demonstrate why that's an interesting problem rather than just being a random person who came off the street and decided to break something. So we try and build interesting malware that will break things in novel ways that we didn't expect. We also, though, try and come up with not ways of detecting attacks, but ways of preventing attacks that are in process, specifically like on constellation levels. So if you have a Starlink constellation and we find that there is an attack that's propagating across all of the different satellites, how do we stop that in its tracks? And how do we not just detect it, but how are we actually able to prune the attack surface while someone is manipulating the system? These are things that we're interested in. We're also looking at the nexus of these kinetic attacks, like rendezvous proximity operation type of encounters where we have two satellites coming up close to each other. How do we begin to understand what the ramifications of that are on a cyber realm or on a directed energy side of things? These are kind of fun areas that we're poking at right now, and would welcome other fun thoughts on how to break things or how to fix it.
Well, you're clearly keeping you and your lab busy, and I'm glad you're on the case. Thanks very much, Greg, for your time today. I hope our audience got something from this. I certainly did. Thanks very much.
Thanks for having me.